program, we're going to do a tutorial on how to simulate the wind tunnel in Ansys Fluent. But first we got to model the wind tunnel. So we're going to start in Autodesk Fusion here. I've already modeled the wind tunnel, but I'm going to show you kind of what I did to model that, just so that you know. So here is the initial sketch that I made. This is based off of the measurements that my team took during our first lab day. And I just went ahead and sketched a bunch of vertical lines to kind of create that profile of the side of the wind tunnel, and then dimension them using those dimensions that I previously mentioned we got from our first lab day. So I went ahead and sketched some vertical lines that were half of the height of the wind tunnel and then reflected it over the center line to create these points down here. And that kind of just gives us an outer profile of the wind tunnel, not fully finished, but just dimensioned correctly. And after this, I went ahead and made a second sketch on top of this one, using all of these points, and created kind of a curved outer portion. So let me show you that now. So here is that second sketch, and as you can see, we got all of the points from that first sketch projected up onto this sketch, and then just went ahead and sketched all of the curves to create that outline. And then once I was done with that, went ahead and created a surface on top of that second sketch. So we used a surface patch, you can see it here, and it just creates like a plane of that second sketch. So this is what we needed to export so we can use it for Fluent. And to export it out, gotta go ahead and go to File and Export, and we're gonna go ahead and click Export down here. Oop, sorry, wrong thing. File, Export, and then we're going to change the type of file to a step file. So it's this, and I've already exported it as a step file, so I'm not going to do it again, but you would just click Export here. One thing I will note, while we're still looking at Fusion, make sure when you do your sketch of your wind tunnel that it is modeled on the XY plane. Otherwise, it will not let you do a 2D simulation in Fluent. I learned that the hard way. So be very careful. For me, in Fusion, it's the top plane that's the XY plane. I have some friends where their Fusion, the XY plane is the front plane. So just be very careful which plane you're sketching on. All right. Now that that note is over, let's move on to Ansys. So here we are in Workbench, and we're going to start off by going into this toolbox on the side, selecting Fluid Flow and dragging that into the project schematic. First thing we need to make sure is that it's correctly set to do 2D, so we're going to click on Geometry, and in the sidebar there's a drop down next to Analysis Type. We're going to click on that and select 2D. So now we should be all set up to do a 2D simulation and not a 3D one. So now we can go ahead and right click on Geometry, and we're going to hover over Import Geometry. If you've never opened your wind tunnel before, you're gonna have to click Browse and go find that step file that you exported out of your CAD software, but I already have used mine, so mine's right here. I'm gonna click on that, and that's all good for the geometry. Now we're gonna have to mesh it, so go ahead and right click on Mesh and click Edit. Wait for it to load up. Right, here we go. There's our wind tunnel. So we've got to mesh this, so we're going to go ahead and right click on mesh, and we're going to insert a method. And now we're going to click on geometry down here where it says no selection. We're going to then click on our wind tunnel and click apply. Now we can change the method that we're using. We're going to use triangles, so take that drop down and click triangles, and that's good for that. Now we're going to click on mesh, and we're going to change the element size to make it a little bit more precise. So we're going to do 0.005. Keep in mind, if you're using the student version of this, you probably have a limit on the amount of cells that you can have in your mesh, so just be aware of that. 0.05 has worked fine, or 0.005 has worked fine for me. So go ahead and click off of that, and it'll load in that new element size, and now we can click generate. Now our mesh has generated, so now we've got to label all of the individual parts of our wind tunnel to make sure that Fluent can interpret it and have the velocity incoming at the right section and outputting at the right section. So we're going to go ahead and click on our model and switch to a smart select, and we're going to hover over the inlet of the wind tunnel, click it, and then we're going to right click and create a name selection, and we're going to call it velocity inlet, and click OK. And now we've got to do another name selection of the walls of the wind tunnel. So we're going to go ahead and click any portion of the wall, right click, and create a name selection, and we're going to call it wind tunnel wall, and click OK. And now we need to add the rest of that wall, so we're going to go into the drop down for name selections, click on wind tunnel wall, and now we can add portions to it. So we're going to click all of the individual segments of the wall and click the plus sign to add them to that selection. Right, there we go. And now we've got to have one more name selection, and that is our outlet. So click on that line, and we're going to right click it, create a name selection, and we're going to call it pressure outlet. And click OK. So now that we have everything that we need to name named, now we can get out of this meshing software and go back to Workbench. So we can minimize this, and we can now right click on mesh and click update. Now we can right click on setup and click edit. And the only thing we have to change in this launcher is we have to check double precision. So go ahead and do that, and now we can click start. Right, you can see that our mesh has loaded up, and you can kind of see these tiny little blue arrows here. That shows that it did process our inlet correctly, and then you can see these red arrows on this side, and it means that our outlet was correctly input into this software. So now that we can see that, we can go ahead and start setting up the parameters of the simulation. So we're going to go into models, and we're going to right click energy, turn it on, and we're going to right click viscous and click edit, and we're going to change it to a K epsilon model and click OK. Now we need to go ahead and change our boundary conditions. So let's go ahead and scroll down. Oh, actually, materials first. Let's check that. We have a fluid and it's air, but let's check what it says about that. It has the density set as 1.225. I'm actually going to change this to 1.204 because our room temperature was about 293 Kelvin, which means that the density is a little bit lower. We're just going to use that for consistency with our experimental data to the simulation. So we're going to click Change Create and then Close. And now we can look at the boundary conditions. Our inlet, we have to change the inlet velocity. So let's right click, click Edit. And it's set to 0 right now, which is wrong. We used our equation that we generated out of our experimental data to calculate the test section velocity, and then you have to use the height ratio of the test section to the inlet in order to calculate the inlet velocity for 2D specifically. If you're doing 3D, then you need to use the area ratio, but for the fact that this is a 2D simulation, you need to use the height ratio. So using that, we got an inlet velocity of 1.858 meters per second. And go ahead and click Apply and Close. And let's just check and make sure our outlet is set. Yep. And the wall, it picked up all of those labels that we put in our mesh. And that's all we need to change with that. We can start initializing this simulation now. So go ahead and double click initialization. And we're going to do a standard initialization. We have to again put in that velocity 1.858. Make sure you do this, otherwise it's not going to work. And we're also going to change the temperature to 293 because, like I said, it was about that temperature in the lab when we did our experiment, so we want to keep it consistent. And now we're going to initialize. Alright, so now that we've initialized it, we can go ahead and double click Run Calculation. Maybe. There we go. And we're going to change the number of iterations. I'm going to use 100. And we're going to scroll down and click Calculate. And we should see it start to show those residuals. There we go. Okay, so we've got our completed calculation. Now we've got to start making all of the contours and plots. So let's start with the contours. We can go into Graphics, right-click Contours, click New, and we're going to start with Static Pressure. So we're going to call it Static Pressure. And we've got that selected already. We're going to select all of these, and we're going to click Compute and Save Display. And we can click Closed, and you can see this is our static pressure contour right here. Now we're going to right-click Contours again. We're going to create another new one. Now we're going to do Dynamic Pressure. So click Dynamic Pressure, check all of these, and click Compute. Oh, let's rename this. Alright, and now we can click Save Display, and we can close it. And here's our dynamic pressure contour, looking good there. We're going to make another one for the total pressure. So we're going to change this to total pressure, rename it. Select all of these, click Compute, and Save Display. That looks good. Our pressure should be pretty constant throughout. And one more for the velocity. I'm going to change this to velocity. And ahead and do that. Click compute and save display. And there is our velocity contour. So we've got all of our contours turned on now. We can start to do the plots as well. So we're going to go into XY plot. We're going to call this one static pressure versus center line. And we're going to go ahead and create a new surface, a line, and this needs to be the center line of our wind tunnel. So this is based off of how you referenced your dimensions, but mine, the center line of the wind tunnel was at y equals 0, so these are going to stay 0, and then it went from, our wind tunnel went from 0, the origin, to 1.85 meters, so that, and we're going to call it center line, and click create, close, and we're going to select this center line here, and it's already set for static pressure, so we're good there, and we're going to click save plot, and you can see it plotted it right there. And then we're also, for the purposes of being able to actually graph these with the other frequencies in Excel, we're going to write it to a file. So you would check write to file, click write, give it a name, whatever you want to name it, find your file location, and click OK, and it'll write it to a file. I'm not going to do that right now because I've already done it. And then there's some more, so we're going to do another plot. We already have the center line, so we're going to click that again, dynamic pressure, and we can call this dynamic versus center line. And we can save the plot. See, there's that one. And again, we would do the same process to write it to a file. Click write, give it a name, find a location, click OK. And we need another one for the total pressure, so we can call this total versus center line, and click center line, change this to total pressure, and then save plot. There's our total pressure. It looks a little jagged there, but that's really just because of the scaling of the axis on the side. When we put it in Excel, it looks pretty straight. And again, you would write it to a file, click write, give it a name, save it somewhere. One more on the center line of the wind tunnel, and that's going to be our velocity. So we're going to switch it to velocity, click center line, call this velocity versus center line, save it. There's our velocity. And again, you would write it to a file, same process. All right, now we need to do our vertical graphs. So we're going to click a new plot. We have to add another new surface, so that's going to be another new line. We're going to call this test center, and this is going to be a vertical line in the center of the test section. So again, based off of how you modeled this, it'll be probably different from what mine is, but for me, my X for the center of the test section was 1.075, and you're going to use the same X coordinate for both, regardless of what your X coordinate is. And then the Y for me went from minus 0.0825 to 0.0825. and we're going to create this line and click close. Now we need to, just based on the way that you want to display this, whether you want the position to be on the x-axis or the y-axis, you can choose, but I prefer it to be on the y-axis since we're tracking y position here. So check position on the y-axis. This needs to change so that it will export the y points and not the x points. I was struggling to figure that out for a while, but you change this to a 0 and then this to a 1, so now it's going to export the y vector and not the x vector. And now we can click that test center line that we created, and we're going to start with the static pressure one, so we can call this static pressure test. And we can go ahead and save plot that. Looks kind of weird and jagged, but again, it's really just based on the scaling. And then we can, again, you would do the same process of writing it to a file. Check write to file, write, give it a name, give it a location, click OK. And now we need another one. Again, I want it on the y-axis, and I want to make sure it's exporting the y coordinates. And we're going to do dynamic pressure and choose that test center line. And save plot. There's that. Looks like one of the normal velocity contours. That's what we're looking for. And we're going to go ahead and, again, write that one to a file, same process. Another one. I think I forgot to name that last one. You can go back and we can go back in and edit that. Yeah, let's see. Let's edit this name. This was dynamic pressure test. All right, now we're going to add another one for the total pressure. And we're going to use the y-axis and do the y position data. And we're going to change this to total pressure and choose test center and save and plot that one. There's that one. Looks very similar to the dynamic pressure. And that's because the sides of the test section, because of the viscous effect, will have zero velocity. So there's no dynamic pressure on the sides. And again, we would write that to a file again, same process. And we have one more, and that's the velocity with respect to y. So let's again check that, rename it to velocity test. And we're going to change this to velocity, change this, and click test center, save, plot it. There's our plot. Again, you can see there's zero velocity on the sides. And we would write that to a file as well. Same process. All right, and that is all the data that we need out of Fluent. So let's look at how we graph that in Excel really quick just to overview it. So we would go into Excel. And we're going to open up a blank workbook. Go ahead and label this 30 Hertz. I would have some 10 Hertz data here, some 50 Hertz data here, but we're going to label this 30 Hertz. And I'll just show you the one of the horizontal ones and one of the vertical ones. So we'd go ahead and open up wherever you saved all of those exported data files. Mine is here. I'll show you the dynamic pressure along the center line. Whoop, sorry, for 30 hertz case. And I'm going to open it in Notepad and go ahead and copy paste all of this data into our Excel. And I'll show the data that I have for 10 hertz and 50 hertz as well, just so that I can show you how to overlay the graph properly. So we'll So we have all of our data. We're going to start by selecting one of the frequencies data. And you're going to insert a chart, scatter. You can see that there. Now we're going to click on this filter, select data. We're going to edit that series and name it 10 hertz because that was our 10 hertz data. We're going to add another series. We're going to call this 30 hertz. So that's the data that I just showed you how to pull. And we're going to select our X values, which is going to be this column right here. It is quite a big chunk of data, but there we go. Click this and then click this arrow and select your Y values. It's going to be the next column. And select that, click that, and click OK. And then you would add the 50 hertz one as well. There we go. Click OK. Scroll down all the way to where that graph generated. It's down here somewhere. There we go. And we're going to call this dynamic pressure versus X. And we're going to turn on the trend line, or turn on the legend to make sure that it's visible. We're going to also turn on axis titles so that we can see what this actually is. So this is X in meters, and this is dynamic pressure in pascals. And there's one of our graphs, and you would do the same thing for the other three. So the total pressure, the static pressure, and the velocity with respect to X. They're all going to look basically the same as that. So I'm not going to show all of them. But that's the same process for all of them. I'll show one of the vertical ones now just to show you they look a little bit different since the position values on the y-axis. The process is still the same, but I'll show it. Let's do the static pressure. So we've got our 10 hertz data right here. As you can see, this is exported the y coordinates of that line. Make sure that exported correctly. This is 10 hertz. static pressure, vertical, so here's this one. Our last 50 hertz one. We're going to go through the same process. We're going to select one column or select one frequency set of data, insert a scatter, but this time we're going to choose this smooth lines and markers just so that it has a little bit more to go off of. I guess I maybe should have shown dynamic pressure because it's a little more interesting, but static pressure, it looks kind of crazy. It should be pretty constant, you would think, because the velocity is the same throughout. And it is, but this is just scaled really, really precisely right now. So we're gonna see that once we insert the other data. So we're gonna go in filter, select data, and we will edit and call this series 10 hertz. I'm gonna add another one, 30 hertz. Select our X data right here. Hertz as well. Let's look at our graph. As you can see, now they look constant, which is right. And we'll call this static pressure versus Y. And we're going to add our axis titles so that we can see what this is and also our legend. So axis title. The bottom is showing our static pressure in pascals, and this side is showing our Y in meters. Alright, so that's how you create those graphs, and that's really all that we need to show for this. So hopefully that was good. Thank you for watching.